to my channel. Today we're gonna work on the question path with minimum effort. So basically you are a hiker preparing for an upcoming hike. You're given heights, a 2D array of rows and columns where heights row column represents the value here. So for example 0, 0, the value would be 1, and then here it's 2, and then the last one on the bottom right is 5. So we are situated in the top left corner, cell 0, 0, and we hope to travel to the bottom cell here, which is rows -1, columns -1, since it's 0 indexed, it starts at 0, 0. And then we can move up, down, left or right, and we wish to find a path that requires the minimum effort, and the effort is defined as the maximum absolute difference in heights between two consecutive cells. So for example, here from 1 to 3, the effort would be 2. The difference, absolute difference, is 2. And then from 3 to 5, it's also 2. 5 to 3, it's 2. And 3 to 5, it's 2 again. So this effort here is the maximum absolute difference, which would be 2. And overall, we're looking for the minimum effort overall. So this path is 2. Let's look at this path. This one, 1 to 2 would be 1, 2 to 2, 0, 2 to 2 is 0, and 2 to 5 would be 3. So here it's 3, and this path is 2, so this would be the minimum path for us. Looking at this question, we can solve it numerous ways, but I'm gonna solve it today using BFS plus a min heap, like a priority queue. And since we're using min heap, I'm gonna do from heap queue import heap push and heap pop. So let's first define some things. Let's first find out like the row and column of the matrix. So row would be length of heights, and column would be length of heights 0. And then let's define our min heap equals it would be, I'm gonna define our min heap with difference, the absolute difference between two cells, two consecutive cells, and then the row, and then the column. So since we're starting at 0, 0, the row and column would be 0, 0, and then the difference would be 0 in the beginning. And what else do we need? We can have a result where we update it real time on the difference, the maximum difference we get each step. So once we find a greater absolute difference, then we will update it in our result. And then we can have a directions that goes up, down, left, right. So -1, 0, and then 0, 1, and then 0, -1. And I think before we start our BFS, we can also define a visit set to make sure that we don't visit two cells twice. And now we can start writing our BFS. Well, min heap, we can pop the first element off our heap, so it would be difference row column equals heap q dot heap pop min heap. And then let's do some base checks. So first check would be if the row column combo is already in our visited set. We would skip. So if RC is and visited, then we can just continue. And another check is to see if we already reached our bottom right corner, which is rows -1, columns -1. Then we can just immediately return the result. So if row equals row -1 and column equals column -1, then we just return result. And then we also need to update our result. So result equals maximum of result itself and the current difference that we get from our min heap. And if it passes these two base checks, then we can just add it to our we know that it's not the last right bottom cell and it's not in visited, then we can add the row column to visited. So we can do visit.add current row and column. And I think now we can start visiting our neighbors. So we can do something like for dr DC and directions, we want to expand from the current like BFS way, like level by level, to up, down, left, right. So this would be our first level, this would be our second level. For DRDC and directions, new row equals R plus DR, and then new column equals C plus DC. And then we're gonna have some boundary checks. So boundary check if new row and new column is within boundaries and not already visited. So we can check if new row is greater than equal to 0 and new row is smaller than row, which is defined here. And new column is greater or equal to 0 and new column is smaller than column, and this new row and new column combo is not visited, then we can add this to our min heap, right? We can add this neighbor because it's a valid neighbor, it's within bounds and it's not visited already. So before we add that, let's calculate the absolute difference. So we can calculate that using what's passed in this heights to the array. So we can do something like a new difference equals the absolute value of heights, the original row and column. So R and C defined like here, minus the heights, the new row and column. So new row and new column. And this would give us the absolute difference, like for example 3 minus 1 or 1 minus 3 would give us an absolute difference of 2. And with this info, now we can start pushing items into our min heap. So heap q.heap push. The format of this using heap push, we first have to define whatever heap that we're pushing to, which is min heap, and then we write what we're pushing to all in this bracket. And the format we're defining before is difference row and columns. So this time we would enter the new difference, new row, and then new column. Yeah, and this is it. Because this is a matrix, we always have an ending point and we always have like heights, the values of each cell. So there wouldn't be a case that we need to return -1. It would always return like the result here when it reaches the bottom right corner. So I think this is all the code. Let's try to run it. Yeah, so this is how you would solve path with minimum effort using BFS plus min heap. This is almost like similar to a variation of a dice stress algorithm. And thank you so much for watching. Let me know if you have any questions in the comments.